Hi all, welcome back to my channel pysparkpulse. In the last video, we've discussed about lower level APIs of Spark, that is RDDs. So in this video, we'll be discussing about the higher level API, that is DataFrame, and like specifically the PySpark DataFrame, right? We will be discussing mostly about PySpark DataFrame in our upcoming videos also, and also about the Spark UIs and also like some of the comments I'm getting. So in that, I will be trying to uh, create a video or explain the upcoming videos as well. So in this video, we'll discuss about data frame. And so what is a PySpark data frame? So we can consider them as a table, and from the definition we can see that PySpark data frame is distributed collection of data organized into named columns, like an RDBMS table that we create. No, we can we can correlate data frame as that. So first of all, like before we begin doing the hands-on on data frame, let us discuss about the why data frame, right? What is the need of data frame and how it is better than RDD. I've created a similar comparison table out of it, so we'll discuss about it. So this is an RDD column and this is our data frame column, and for the abstraction level this is low level API that we have discussed, and this is the higher level API. Immutability and lineage, both are immutable and both are lineage for fault tolerance. Okay. Optimization, for RDD we have limited optimization opportunities, but for data frame we have a lot of opportunities, and these are some of the optimizer and execution engine that we can do. Otherwise also we can see like in the data frames, no, we will a lot of optimization things can be done, and that can be done in a very easier way. So in the upcoming in the upcoming videos, well, I will be discussing about different type of transformation, the explain plan, and how how Spark executes our query internally, how it works. So in that video, we will discuss about the optimization. Language support, we have Python and Java for RDD. For data frame, we have Python, Java, Scala, and R. So, and for performance overheads, may occur higher computational overhead. Yeah, because RDD, a lot of IO needs to be done because uh, it will be shuffling a lot of times the data, right? And optimize operation for better performance. Ease of use, it requires more explicit coding because always you have to think about the key and value pair. Okay. And for data frame, it is not like that. Concise and readable code, SQL like operations. Yeah, Spark SQL is there. Okay, and Spark SQL is different thing, but in PySpark DataFrame also there will be like a lot of similar transformation that is like SQL kind, so that we can relate to the SQL who have experience in SQL. Structured data, so suitable for unstructured and structured. These are primarily designed for structured data. No unified API across multiple languages. Both have like good integration with Spark ecosystem, but obviously DataFrame has good connectivity. I've given this definition of this catalyzed optimizer, and tungsten execution engine. So catalyzed optimizer is query execution framework, okay, in Apache Spark, and this tungsten is an execution engine in Apache Spark that focuses on improving the efficiency and performance of in-memory computing. Okay, so in the next slide, we'll discussing about how to create an PySpark data frame out of an RDD. We already know how to create an RDD. Okay, sample data in the form of list. Inside a tuple is there with pairs. So we'll do the parallelize of this and define the schema, name and age, and we'll be creating an RDD schema and schema. We'll provide this parameter and we'll be creating the data frame out of it. Yeah, and this for showing the data frame, like for RDD we were using dot collect. So here we'll be using dot show. Okay. Next method is from a list. Yeah, from a list. So in the same way, directly we can pass on the data and take schema and we can show. The next way is like from different reader APIs, right? Like it is CSV file. Generally, two parameters we use, header and info schema. Then JSON, then Parquet, then custom format, any format you want, Avro, ORC, any format. Then give the file path. Then providing a schema, and then also we can create the file. So these are like like things that we have discussed in the tutorial kind of way. Like now we are doing the hands-on. Okay. So first of all, like from the RDD. how to create data frame from an RDD. Okay, so create an RDD. Data is equal to L is 25, Bob 30, that we have seen in that slide. So RDD dot parallelize data. SC we have discussed, that is a Spark context variable. SC Spark context variable. We have defined the schema then, and df from RDD Spark dot create data frame RDD schema, and let us run this. Okay, so name, age, L is 25, Bob, this all okay, and data L is 25, Bob 30, Charlie 35, name is okay. So this is from like how to create an list. It is very similar to create an RDD. Okay, so one of the CSV file I am having in a DBFS, budget.csv. I will navigate to DBFS and file store. In this raw, I think I'm having that file. Okay, budget.csv. Okay, so I'm reading this file. I have put in file schema equal to true and are equal to true. Let us check if we don't put header equal to, then what will happen. So it will pick up the headers also as consider the first column. So that's why it is necessary. Like if whatever CSV file is having header, then we can put this. Otherwise, we can remove this. Now one of the partition file I was for my practice purpose. I have one of the saved one of the Parquet file. So that I'm trying to read. So Parquet and dev.parquet.save. So in this like explicitly we have given the schema right for the CSV file. Like in file schema we have given, and for the in the below example you can see that we have given the custom schema, but for Parquet files like this is not required. So let us see what the schema this will have. Print schema. See, integer, string. So whatever the string format is there, right, and pin code it will be integer. See, so already like in the Parquet the schema is inbuilt. So this is like a custom where you can give our schema and all. Very similar, reading the CSV file, giving header as true, and then we can run. So that's all for this video. We have learned about a lot of things in like how to create the RDD, how to read RDDs, how to read from RDD and create a data frame using custom schema, reading Parquet file. Similarly, we can read the JSON file also, right? JSON file, and in ORC file we can load this. Avro file we can load like this. Okay. So yeah, thank you for watching my tutorial, and do subscribe and comment and what you like about my video, and please share with your network, and let me know if you have any doubts and any new topic you want me to create a video on. Yeah, thank you.